Hello, everyone. I hope everyone is having a wonderful day. And we're going to continue talking about ionic compound properties. We kind of started in class. So, ionic properties. And from class, we said that ionic compounds or ionic solids form crystals. And we said that each crystal has a crystal lattice structure. So, you have to have these alternating positives and negatives. So this would be an example of a crystal lattice structure. And these structures give a lot of ionic compounds physical and a little bit of chemical, but mostly physical properties. So we're going to talk a bit more about properties of ionic compounds. And really talk about why. And the first one I want to talk about is that all ionic compounds have very high melting points and boiling points. How high? Well, let's go to the internet and find out. Let's see, what was I Googling? Aha. We have seen already. All right, let's Google NaCl. No, I don't want the model. Just NaCl. There we go. And let's see. Its boiling point is probably 200 to 300K. Somewhere in there. Oh, I was even. Its melting point is 1,073K, which is right, 1,473 Fahrenheit or 800 degrees Celsius, right? And they're all real high, really up there. They have very high melting points. That has everything to do with the crystal lattice structure. So if I redraw that crystal lattice structure with my alternatings, I'm going to do a 3x3. And for some reason, I'm really good at drawing the rest of them when I have the first row complete. Here's my 3x3. And we can see that in any ionic solid, each ion is actually attracted to more than one opposite charge. Right? And we can see in this picture, there are 1, 2, 3, 4 negatives next to this positive, 4 anions next to that cation. But in actuality, it's a little bit more. Here we have the three-dimensional model. Will be our Cl. This will be, look at this. We have an Na here, an Na here, an Na here, an Na here, an Na here. One right there. So in total we have 1, 2, 3, 4, 5, 6 that are all being attracted to this one chlorine. So in NaCl, we see that there are 6 ions, 6 anions for every cation and 6 cations for every anion. Because of this, because each ion has so many opposite charges, there's a lot, or many attractive forces holding the crystal together. So it's held really tight and just takes a lot of energy to break apart. Okay? And unlike metals, ionic compounds are very brittle. They are easy to crack, not bendable at all. They're not malleable, and they are not ductile at all. And that also has to do with that crystal lattice structure. So once again, let's draw our 3x3. And the reason that they are so ductile has to do with how they have alternating charges, alternating ions in their crystal lattice. For example, if I were to take like a hammer, there's my hammer, and I were to push down on that hammer, right? So that hammer's going to be going downwards. This is what the resulting one's going to be like. Positive, positive, positive. Sorry about that. My headphones decided to turn off. Negative, negative, negative. But if we look here, see this? That's going to be moved down one row. It's going to look like this. There's going to be a positive here, a negative, negative, positive. Where'd you zoom out? And another positive, right? And we see here that with these two, there's going to be this force of repulsion, right? So the instant you knock them down one, they get pushed apart. And the farther you go down, the more they get pushed apart, and that's why they're able to crack. So we can write that when forced to bend, like charges line up, just like we see there. And it causes a force of repulsion, thus cracking, right? And just a few more notable properties that they are very dull looking. For the group 1 and group 2s. 1 and group 2 ionic compounds. However, that being said, we have some pretty colors for transition metal ionic compounds. All of our old Impressionist painters from the Renaissance and up, right? Their paints, all those paints used to be made with transition metal compounds. Fortunately, many of them are very toxic, and that may have led to a lot of mental deterioration, which is why we had some interesting characters. One of the many reasons we had interesting characters back in the day. So not only that, they're dull, they're pretty in color, but also ionic solids, and this goes for solids, are electrical and thermal insulators. Has to do with the fact that, once again, just like with the melting point, all of these crystals are held really tight. They can't do much, okay? So that's going to be it for our properties lesson. I hope everyone has a good day. Bye, everyone.